Good evening, I am Tomas Guevara Calderon, and this is the channel Rewriting the Reality. In today's episode number 121, I am going to add more information to the nature of the black holes. Don't forget to subscribe to this channel. In episodes number 26 and 103, I explained the nature of the black holes. First, I am going to tell you that the notion that mathematics is the language of the universe is wrong. To the scientific community, black holes are some of the most enigmatic objects in the universe, capable of deforming the fabric of space around them so violently that not even light can escape their gravitational grip. But it turns out, much of what scientists know about these mysterious objects could be wrong. Let me include here my first note. Subjectively, our scientists know that they are wrong, and according to new research, published in April in the journal Physical Review D, black holes could actually be entirely different celestial entities known as gravastars. Gravastars are hypothetical astronomical objects that were introduced in 2001 as alternatives to black holes, study co-author João Luis Rosa, a professor of physics at the University of Gdańsk in Poland, told Live Science in an email. They can be interpreted as stars made of vacuum energy or dark energy, the same type of energy that propels the accelerated expansion of the universe. Karl Schwarzschild, a German physicist and astronomer, first predicted black holes in 1915, based on calculations using Albert Einstein's general theory of relativity. Over the years, astronomical observations have seemingly confirmed the existence of objects resembling black holes. However, Schwarzschild's description of these space bodies has some shortcomings. In particular, the center of a black hole is predicted to be a point of infinitely high density, called a singularity, or all the mass of the black hole is concentrated, but fundamental physics teaches us that infinities do not exist, and their appearance in any theory signals its inaccuracy or incompleteness. These problems indicate that something is either wrong or incomplete in the black hole model, and that the development of alternative models is necessary, Rosa said. The Gravastar is one of many alternative models proposed. The main advantage of gravastars is that they do not have singularities. Like ordinary black holes, gravastars should arise at the final stage of the evolution of massive stars, when the energy released during thermonuclear combustion of the matter inside them is no longer enough to overcome the force of gravity, and the star collapses into a much denser object. My note number 2, what they call collapse is the death of the start, just like our body die. They continue, but in contrast to black holes, gravastars are not expected to have any singularities and are thought to be thin spheres of matter whose stability is maintained by the dark energy contained within them. To find out if gravastars are viable alternatives to singular black holes, Rosa and his colleagues examined the interaction of particles and radiation with these hypothetical objects. Using Einstein's theory, the authors examined how the huge masses of hot matter that surround supermassive black holes would appear if these black holes were actually gravastars. They also scrutinized the properties of hotspots, gigantic gas bubbles orbiting black holes at near-light speeds. Their findings revealed striking similarities between the matter emissions of gravastars and black holes, suggesting that gravastars don't contradict scientists' experimental observations of the universe. Moreover, the team discovered that a gravastar itself should appear almost like a singular black hole, creating a visible shadow. This shadow is not caused by the trapping of light in the event horizon, but by a slightly different phenomenon called the gravitational redshift, causing light to lose energy when it moves through a region with a strong gravitational field, Rosa said. Note number 2, light doesn't lose energy. It is simply decomposed as any other set of particles or waves. They continue, indeed, when the light emitted from regions close to these alternative objects reaches our telescopes, most of its energy would have been lost to the gravitational field, causing the appearance of this shadow. The striking resemblances between Schwarzschild's black hole model and gravastars highlight the latter's potential as a realistic alternative, free from the theoretical pitfalls of singularities. However, this theory needs to be backed up with experiments and observations, which the study authors believe may soon be carried out. While gravastars and singular black holes might behave similarly in many respects, subtle differences in emitted light could potentially distinguish them. To test our results experimentally, we are counting on the next generation of observational experiments in gravitational physics, Rosa said, referring to the Black Hole Hunting Event Horizon Telescope and the Gravity Plus instrument being added to the Very Large Telescope in Chile. These two experiments aim to observe closely what happens near the center of galaxies, in particular, our own Milky Way. I asked co-pilot about the difference between black holes and gravastars. Here is the response. Black holes and gravastars are both fascinating theoretical objects in astrophysics, but they have some key differences. Black holes. Event horizon. Black holes are defined by the presence of an event horizon, a boundary beyond which nothing, not even light, can escape. Note number 3, this is only a belief. Singularity. At the center of a black hole, there is a singularity, a point where the density is thought to be infinitely large and the laws of physics as we know them break down. Another belief. Information paradox. Black holes pose the information paradox, or it's unclear what happens to the information of matter that falls into a black hole. Note number 4, the information about everything is held in the regional area number 2 of the universal consciousness. And nothing fall into a black hole because it is a deposit of energy. Gravastars. No event horizon. Gravastars do not have an event horizon. Instead, they have a distinct surface that separates the core from the outer shell. Exotic core. The core of a gravastar is hypothesized to be made of exotic matter, such as a Bose-Einstein condensate, which counteracts gravitational collapse. Note number 5, it's made of links of consciousness. Information preservation. The absence of an event horizon in gravastars suggests that they could potentially avoid the information paradox associated with black holes. Gravastars, short for gravitational vacuum stars, were proposed as an alternative to black holes to address issues like the singularity problem and the information paradox. Unlike black holes, gravastars are envisioned to have a central core surrounded by a thin shell. The core is thought to be a region of exotic matter that prevents the formation of a singularity, while the shell acts as a stabilizing boundary. The concept of gravastars is still theoretical, and whether they exist in nature is a subject of ongoing research. They offer an interesting perspective on collapsed stellar objects and could provide insights into the fabric of spacetime if proven to exist. My final note is that they will be continuing making assumptions about our universe because they don't understand yet the nature of the universal consciousness and its building blocks called links of consciousness, themes that I explained in episode number 4 and recently in episode number 117. Don't forget to subscribe to this channel and share this information.